Hi students, in this class we have to discuss about the various theories of biological evolution, the support of evolution, not the origin of life but the support of evolution. The following are the different theories which are in support of biological evolution. Number 1, Lamarckism. Number 2, Darwinism. Number 3, mutation theory. And number 4, modern synthetic theory. Of all these theories, the most accepted theory of evolution is modern synthetic theory. It's the most accepted theory of evolution. Now we have to go for one by one. What are the principles and propositions made by different people in support of biological evolution? Now, let's take the first one, Lamarckism. Now, this concept, Lamarckism, was given by Jean Baptiste Lamarck. He was the first person postulating the mechanism of evolution in his book. He wrote a book that is in 1809. He explained the mechanism of evolution. He was the first person to explain the mechanism of evolution in a book, Philosophy, Zoologic. This is the name of the book. The book was written in the year 1809. In that one, he explained the mechanism of evolution for the first time. Now the basic concept, what he explained that one, what is the main concept of this actually Lamarckism? Inheritance of acquired characters. Inheritance of acquired characters. The basic concept, inheritance of acquired characters. So this is the basic concept in his book. So what is the meaning for that one? Any structure that is normally acquired during the lifetime of an organism will automatically be transmitted to the next generation. Any structure that is acquired during the lifetime of an organism can automatically be transmitted to the next generation. That is the concept proposed by Lamarck. And it has different propositions. What are the different propositions proposed by what is called Lamarck? What were the different propositions proposed by Lamarck? Now, number 1, when there is a need, and before that I want to discuss first one. Now, during the course of evolution, the organism or their organs tend to increase in size. There is increase in size of a particular organ or the entire organism during the course of evolution. Further, it is given the example of the evolution of horse. The animal with the oldest evolutionary history. The animal with the oldest evolutionary history, that is evolution of horse. In evolution, we are giving more importance to the evolution of horse because the evolution of man and horse took place simultaneously. That's why in evolution, we are giving more importance to the evolution of horse. So the animal with the oldest evolutionary history, and also we are giving more importance to that evolution of horse because evolution of horse and man took place simultaneously. Now, what is the meaning here? Now, the ancestral horse, normally called Eohippus, also called by another name, Hypothesized. Also called by another name, Hypothesized. Hypothesized. This is the ancestral horse which is short in size. This horse underwent that is series of steps. In course of evolution, it became the largest modern horse. By passing through different stages, the stages are Miohippus, Mesohippus, Merchippus, Pleohippus, like that, we don't know. So there are some intermediate stages also between Eohippus or Hypothesized, the ancestral horse, to the modern horse, Equus, Cabalus. So increase in size of this animal took place. from the smallest ancestral horse to the modern horse. This is the first proposition, increase in size of the organ or the entire organism. The second proposition, if an organism is in need of an organ, sooner or later it will appear. So it is a mere want to meet the needs. For example, if you are taking the giraffe, the ancestral giraffe was short with a short neck with a short forelimbs. So it was roaming in the grasslands of South America. Once all the grasses were exhausted, there was no food available on the ground. They had to stretch their neck to get more food from the just trees. While stretching for a long duration, in order to have what is called a long neck, stretching for a long duration. Ultimately, finally, they developed what is called the long neck. So the present giraffe has long neck. This is because an organism is in need of an organ, sooner or later it will appear in order to meet the needs. So to meet the needs, now the long-necked giraffe normally evolved. So the lengthening of neck in giraffe is an example for the second proposition. But actually, in evolution, now lengthening of neck in giraffe, as per the examination point of concern, that is need or generally, it is an example for what is called Darwinism. Though here it is given under what is called the proposition 2 of Lamarckism, it is an example for Darwinism. Okay, that is we will discuss. Now let's go to the other propositions. The third proposition is called use and disuse. Use and disuse of organs. What is the meaning for use and disuse of organs? Now this is proposition number 3, use and disuse. Use and disuse. What is the meaning of that one? If an organism uses one of its organs continuously, its efficiency increases, its perfectness increases, its size increases. Okay? If an organism is not using a particular organ continuously, its efficiency decreases, its perfectness decreases, also the organ degenerates. That is called use and disuse. For example, the vestigial organs is an example of vestigial organs, an example for disuse. It's an example. The lengthening of neck in giraffe is an example for use. Because of the continuous use, the neck has been increasing in size, increasing in length. So, lengthening of neck in giraffe is an example for use. And the loss of limbs in the case of snakes is an example for disuse. Again also, if we are taking the flightless birds, say the kiwi, ostrich, that is also an example for disuse. And also we have the different vestigial organs in human beings, what we discussed in the last class. Also an example for disuse. So this is the third proposition, use and disuse. Any character or any change in the structure of an organism due to adaptations, the change in environmental conditions can automatically be transmitted to the next generation. Simply, any structure that is acquired during the lifetime of an organism can automatically be transmitted to the next generation. And those adaptations which are useful to the organisms, they are called what is called heritable adaptations. The changes are called heritable variations. So, Lamarck didn't give any just actually solutions for this one, inheritance of acquired characters. Any example was, he simply said that, so changed characters during the life of an organism can automatically be transmitted to the next generation. He didn't say anything about the somatic characters or germinal characters. Simply say any character occurred during the development of an organism or during the lifetime of an organism can automatically be transmitted to the next generations. But the concept of inheritance of acquired characters was disproved by a person by name Auguste Weismann. Auguste Weismann in 1890, that is, disproved the concept of inheritance of acquired characters. Now he proposed theory, what is called germ blossom theory. Germ blossom theory. So based on this theory, he explained any change in the somatoplasm will not be transmittable. Somatoplasm means normally any change in the body cells. If a person is getting a scar because of an accident, that scar will not be transmitted to his son or daughter. That's the meaning. If there is any change in the germ plasm, what is called the germinal cells, either the egg or the sperm, will be transmitted to the next generation. That is called germ blossom theory. So any change in the somatoplasm will not be heritable, but a change in the germ blossom, that is nothing but the germ cells like sperm and egg, will automatically be transmitted to the next generation. That is the main concept of germ blossom theory. By using this theory, he explained, that is actually he disproved the concept of inheritance of acquired characters of Lamarck. He did experiment on mice. The name of the experiment, decaudalization experiment. Decaudalization experiment in mice. What he did, he took a mouse and then cut its tail and allowed, so for example one male, one female, cut the tails of a male and a female and allowed these two individuals to breed, to reproduce. He received in the first generation all mice with the tail. All mice with the tail. So this is the first generation. So he took one male, one female from the what is called the first generation. He cut the tail once again and allowed them to breed. Now he got the second generation. The second generation also, all mice were born with the tail. Likewise, he did the decaudalization experiment for 20 generations. 20 generations. In all the 20 generations, even the last generation F20, that is, all the mice were born only with the tail. So here, the tail is nothing but the somatoplasm, somatic cells. So any change in the somatic cell will not be transmitted to the next generation. So as per what is called the inheritance of acquired character, any change in the structure will be automatically transmitted to the next generation. But here he disproved the concept of inheritance of acquired characters by decaudalization experiment. Then up to 20 generations, in all the 20 generations, the mice were born with tail only. No individual was born without what is called tail. So he proved that is only change in the germ blossom will be transmittable. And the germ blossom, the somatoplasm, if there is any change, the somatic cells, no transmission occurs to the next generation. By which he disproved the concept of inheritance of acquired characters of Lamarck. Most scientific form of Lamarckism is called neo-Lamarckism. The followers of Lamarck are called neo-Lamarckians. The neo-Lamarckians we have Coe, Osborne, Packard and Spencer. These people were called neo-Lamarckians. These people tried to explain the Lamarckian concept in more scientific basis. Now all believe that, these people believe that adaptations are universal in nature, that is found in all the organisms. They developed adaptations in order to just suit the changed environmental conditions. That's why I say adaptations are universal in nature. Adaptations are the products of evolution. Adaptations are the products of evolution. Now, what is happening? Organisms acquire new structures due to adaptations to the change in environmental conditions. When there is a change in the environment, ultimately to adjust or cope up with the environment, the organisms modify their structures to suit the environmental conditions. That's why I said here, organisms acquire new structures. What for? Due to adaptations to the change in environmental conditions. Then only they can survive, otherwise they will be eliminated. Now, what will happen? The conditions in the environment stimulate the somatic cells of such animals to produce certain secretions. There is no name was given for these secretions by them. Simply they said some secretions which were transferred to the germ cells like sperm and egg through the bloodstream, and which produce or which normally generates variations in the offspring. That's the thing they say, without knowing what is called the particles, the genes, etc. Simply something produced in the somatic cells. They were transmitted to the what is called the germ cells and the sperm or egg through the bloodstream, and which bring about variations in the offspring during reproduction. That was a concept given by the neo-Lamarckians, and that concept is called neo-Lamarckism, the modified form of Lamarckism in a more scientific basis.